There is a sheet of carbon nearly 1 atom thick that has a memory. It stores either a 1 or a 0, aka a bit, and it does so by changing its own shape. Apply a voltage and a patch of it folds, and when folded, it forgets how to conduct. Reverse that voltage, and it flattens back and the current returns. The fold is the memory and the shape is the data. Isn't that kind of weird? We are so used to memory as being something like a magnetic mark or a groove. But this is different. Here, the material remembers by becoming a different shape altogether, and the structure functions as more than a container for the information, because the structure here is the information. And it matters right now for a reason that's not altogether philosophical yet. Because your brain runs on about 20 watts, a dim light bulb. The systems we build to imitate even a sliver of that run on tens of megawatts, which is the amount of a small power plant. And they spend most of that energy just shuffling data between the place where it's stored and where it's actually worked on. The brain doesn't need to do that at all because it computes where it remembers. And in that sense, substrate and thought become one process. That carbon sheet that's 1 atom thick, it does something similar. It senses and stores and computes in one spot by reshaping itself. What kind of thing is a shape that matter can think with it?
We're going to start
Begin
with the
with two
flower of life.
circles, each
If you
passing
haven't
through
seen
the
the
other's
first lesson,
center.
you can find the
The
link in the
almond shape
description.
between them is
Feel
called
free
the
to check it
vesica
out when you
piscis.
proceed.
The
We
height
will
of that
begin with the
almond
same diagram,
against its
6
width
circles
is the
arranged
square root of
around a
3.
central circle,
We
which
didn't
will
choose
help
this to
us
be the
create a
square root of 3
hexagon.
or adjusted our
We're going to get
calculation to
into
make
it
it
in our path.
so. It just fell out of the constraint. And now we'll keep swinging the compass and the circles bloom into a lattice
Building a
and
hexagon
connect their
grid using
centers
the
with straight
structure we have
lines,
just
and the
traced.
plane fills with
I am using
triangles
a color here to make the
and with
pattern more
hexagons.
visually distinct,
So the
but you can
same root
achieve the
3
same
is
effect
now
by
a
using a
grid.
harder
It
pencil
is
or
what you
double
get
layer
when
glue
equal
strokes.
circles pack as
You can already
tightly as
start to see
circles
the first
can.
hexagonal
In my
grid
last
taking
video, I
shape.
argued that we of course don't invent these shapes. We keep discovering them in different places. And this time I want to prove that further. And I want to show you something that the heart in the last video couldn't show us. And that's that shape just doesn't sit there waiting to be filled. It's working and it's computing. The first principle here is something that is often cheapened by a lot of mystical circles and everything. And it's something that says, look, there's all these hexagons and they're everywhere. Bees, snowflakes, basalt, carbon, they must all be connected and it all must mean one thing. But that's not really an argument that we can really prove. That's looking at different patterns and making connections. And you can do that really with any shape or any kind of number, looking anywhere you want if you want it badly enough. The real claim is narrower and much stronger. When a system is pushed to do the most with the most area for the least edge, the most packing for the least cost, it arrives at the same form. Not because anything chose the form or created it, but because the form is what optimization finds. If you want to divide a flat surface into equal regions using the least wall, the hexagon comes out on top. It's the least perimeter with the least waste. Bees, of course, were not solving for that equation or tinkering with the variables of that to come up with different results. They were building by insect instinct, and the form was already the answer waiting for them at the bottom of their problem. Because wax is expensive and the hexagon is what spend the least wax looks like when you let it run to the end or let nature run its course. That's the principle. Optimization finds the form. There's no author because the form is sitting there in the structure of what's possible. And then matter, which is the insect or a measurable number, that settles into it the way a stream finds the low ground. Now watch what happens in the one substance this whole video is built on. Carbon. One element, 6 protons, and the most consequential thing about it is the angle that it bonds at. A carbon atom has 4 bonds to give. It has 2 main ways to arrange them. The first, 3 bonds, laid flat out, spread evenly at 120 degrees. Lay those atoms down edge to edge across a surface and the geometry forces a hexagon. A flat sheet of hexagons, 1 atom thick, is called graphene. And because each atom holds 1 electron loosely above that flat plane, the whole sheet conducts. The electrons skate across it, and chemists call this arrangement sp2. And here's the number again. The distance between the repeating points of that lattice is the length of a single carbon bond, multiplied by the square root of 3. The same square root of 3 we drew with a compass now is the literal spacing of atoms in one of the strongest material we have ever measured. The Vesica Pisces here is the same square root of 3 constraint we drew with the compass, and it reappears in the actual spacing of the lattice. Now the second arrangement. The same carbon, but the 4 bonds point instead to a little corner of a pyramid, a tetrahedron, about 109 degrees this time. So nothing is flat and nothing is loose, and every electron is locked into this cage. This is considered sp3. An sp3 carbon stacked up is a diamond. Diamond and graphene are the same carbon element, both of them. So the hardest thing and a single atom sheet that conducts like a metal, the only difference between them is the angle the bonds decide to take, either flat at 120 degrees or folded like a pyramid. That's it. Conduction, hardness, transparency, everything downstream, all of that follows from the shape. So when we change the shape, the function changes as well. There's one more thing that the hexagon does, and I saved this one for last, because it's the cleanest proof in the whole video that these forms are not ours that we invented. Try to wrap that flat hexagonal sheet around a ball. Try to close it into a sphere, all hexagons and no gaps. It's impossible. And the impossibility is a law of the universe. A surface that closes on itself cannot be tiled by hexagons alone. To shut the sphere, the geometry forces in exactly 12 pentagons. Carbon does exactly this. Take 60 carbon atoms and let them close into a cage, and you can get a ball of hexagons stitched shut with precisely 12 pentagons. It has a name called the buckyball, and it's the same geometry as a stitched soccer ball. In my last video about the geometry of the human heart, I brought up the dome a mile underground that tests neutrinos. I mentioned that it was a hexagon sphere. However, this dome is a geodesic that's built from triangles. And the triangles and hexagons are not two different answers because they're the same root 3 lattice seen from opposite sides. The triangle grid is the hexagon grid's shadow. So either way, it's the same constraint. I just wanted to clarify that, yes, that was a triangular geodesic grid, and it didn't neatly fit around the sphere as the hexagons. But the form is found and no one is choosing that. It's just an extremely secure geometry to do these tests. So now back to where we started. The carbon sheet that remembers by changing shape. Because here's where we continue on where I left off in the heart chestahedron video. In the heart video, that form was something that was more thought of as passive, a shape waiting and the body and the blood filling it. Beautiful, but the shape there sat still and was filled. This shape that we're discussing now doesn't sit still. It does the work. And go back to those two arrangements. The flat conducting sp2 and folded insulated sp3. Take a single patch of the sheet and push it from one to the other. Flat, it conducts. We'll call that 1. Folded, it stops. Call that 0. You now have a bit of memory, written in nothing but geometry. No new material was added here and no new charge stored in a well. It's just the shape of this lattice here, flat and folded, holding the data in its own body, so to speak. In the real devices, the fold is usually driven by oxygen. Atoms of it latching onto the sheet to force it into this pucker, then migrating away under a voltage to let it flatten back. So I won't tell you the carbon folds itself on command by its own free will or any type of thinking. The truth is kind of stranger for being real. The lattice is pushed between flat and conducting, and folded and insulating, and which shape it's in is the stored bit. The geometry literally is the memory. A 2020 Nature Communications demonstrated graphene-based memorative synapses with more than 16 programmable conductance states on a single device. So it's going beyond just on and off and into a fine gradient, enough to function as analog weights in a neural network. A growing body of work points in the same direction. Materials that can sense and store and compute in the same physical location, closer to how a retina works, where meaningful processing begins before a signal ever reaches the brain. Remember the 20 watts that our brain operates on? That puts our technology to shame. Biology computes in the substrate. It doesn't carry data across town to be processed and carry it back. The carbon sheet is the first hint of something material that could do the same. Sense, store, and think in one shape at something approaching the brain's terms. Rudolf Steiner argued that form precedes function. And the heart let me show you form being filled. The carbon here lets me show you something further. Form performing that function. a shape that doesn't wait to be used passively, but rather a shape that actually computes. The form comes first, and they sit in the structure of what's possible. The hexagon at the bottom of the least wall in the honeycomb conjecture, and the 12 pentagons at the bottom of close the sphere. The square root of 3 at the bottom of two simple circles. They were true before anyone drew them, and before any bee or before any carbon kind of illuminated this to us. Optimization finds these forms in our evolution, and matter then pours into them like water into the lowest ground. Everything in this video, I kind of assume that the form is out there before the matter is there to fill it. But ontology opens a harder question. How do we encounter form in the first place? How do we think about it? How do we know? And that's where this goes next. And the inquiry that came before this one with the heart and how there is form before function, that is in the video I will link below.